A common free response question that you might see these days on the AP test will give you a list of lab materials, and then they'll say, explain how to set up a procedure to test for whatever. So maybe it's like, something kind of like this. Explain how you will prepare the solution using the equipment listed. Explain how you will test the percent copper in this compound, or something like that. And it should usually be some kind of a procedure that you've done before, something you're familiar with. So in this case, we just want to prepare a solution of hydrochloric acid. We want 500 milliliters of a solution that has a pH of 1.5. We're going to start with concentrated 12 molar acid, which makes sense. I mean, when we buy our acids, we always buy as concentrated as we can get. Rarely do we need to use it 12 molar. That's kind of nasty. Like the 12 molar, that'll start to burn your nose hairs. That's good stuff. So we dilute it. There's a question like this in the homework, and often people kind of spin their tires and they just don't know how to get it started. They kind of get the whole diluting thing. That I'm going to start with concentrated 12 molar, and obviously I'm going to probably dilute it down to some smaller molarity so that the solution has a pH of 1.5. They just don't know how to get started. Like, what's the molarity of the original solution? If you know the pH, you know the molarity. You can do this, and people always forget about it. You can calculate the hydrogen concentration. You can just go 1.0 times 10 to the negative pH, 1.5. You can do that. pH is opposite log of the hydrogen concentration, which is like the opposite exponent of 10. And now again, this isn't what we would find as like a final answer. We would want to plug this in our calculator to simplify that exponent. So if I go 10 to the negative 1.5, I get about, I don't know, maybe we'll go 3 sig figs. It's 12.0 molar, 0.0316. There's the molarity of the original hydrochloric acid solution. HCl has one acidic hydrogen. So if I find the concentration of the hydrogen ion, it is the concentration of the HCl solution. Ah, okay, so that's what we want. But we're starting with concentrated 12 molar. This equation is not in the AP packet. I kind of wish it was, because it's very useful and we're going to use it a lot. So you might as well get kind of comfortable with M1V1 equals M2V2. We can use this for dilutions. If we know the original molarity to be 12 molar, we'll solve this for V1. How much of that original solution should I measure? I know the final molarity, 0.0316, and we know that we want 500 milliliters. All right, well, that's not so bad. We'll solve this thing for V1. And maybe I mean, there's no decimal, but I might just add one in and say 1.32 milliliters. Okay, so sometimes now people can do the calculation, but they don't really know what that means. Explain now how to prepare this solution. So we want to do this. We're going to look at the list of equipment that they have available to us. Step 1 will always be put on goggles and gloves and whatever other safety equipment they have listed. Use it all. Goggles, gloves, aprons, I mean, whatever they have listed, use all of that safety equipment. That's always step number 1. Put on your goggles, gloves, hazmat suit, whatever they have. Number 2. And again, look at the equipment that they have listed. We'll probably have some kind of a graduated cylinder. Use a graduated cylinder. we're going to measure 1.32 milliliters of the 12 molar HCl. Okay, so number one, make sure that if you're measuring a quantity that's very specific, we'd use a graduated cylinder, not a beaker. And number two, make sure you specify that the 1.32 milliliters, that's the original 12 molar HCl. Okay, so now watch how this gets worded. Step 3. We're going to say add the acid to approximately, I don't know, maybe like 400 milliliters of distilled water. Distilled water. We should always use distilled water when making our solutions, and it's more pure. Notice that I want 500 milliliters. My final volume is going to be 500. But initially, I added the acid to only about 400 milliliters. Then in the final step 4, we're going to say dilute to 500 milliliters total volume. And maybe we have like a stirring rod or something, and we'd be like, stir the solution or something like that. Okay, so here's the deal. When you make acidic solutions, especially from a concentrated acid, when you put that acid in the water, it's very exothermic. It releases a ton of energy. So if you just had your small amount of acid and you start putting in water, sometimes you'll see that water like start to bubble right away. It like almost boils. It like fizzes and bubbles and it gets super hot. Well, if some of that water is evaporating or boiling because of the exothermic reaction, your final volume might not be accurate. So to help absorb the heat, we always want to add the acid to a larger quantity of water. It doesn't have to be like, the exact final quantity. So, I don't know, measure like approximately 400. Something a little bit less than your desired volume. Add the acid to the water. With that much extra water, it'll absorb the heat from this being an exothermic reaction. So I had this professor in college. She was this tiny little redhead. She kind of looked like an adult version of Annie. Like she had really curly red hair. She was really strange. Dr. Tammy Melton from Texas. I don't know how she ended up in Wisconsin. But Dr. Tammy Melton would always say this, and I still remember it. Do as you oughta. Put the acid in the water. So I remember her, you got a picture, like Orphan Annie, like tight, curly, red hair, tiny little thing. Do as you oughta, put the acid in the water. And I still remember, I'll never forget. And they will want you to do that on the AP test. If they ask you about like diluting a solution, an acidic solution, we should be aware that it's exothermic. So we should do as we oughta. Put the acid in the water. That'll help absorb the heat. And then again, we can finally dilute it then to our desired volume. But initially, add the acid to something a little bit smaller than what you finally want for your volume. You don't have to measure this out to be like 498 point whatever milliliters. No, we don't do that. In real life, we don't do that. We'll put the acid into a smaller amount of water, and then we'll just dilute it to the desired volume. But make note of that. You should always put the acid in the water to help absorb the extra heat and make sure that your final volume is accurate.